Hello once again. We're back this time to go over algebraic expressions. First of all, an expression is just a collection of terms with no equal sign, no unequal sign, no inequality of any kind. Expressions do not have any of these. They never will. If something has one of these symbols, it automatically stops becoming an expression and becomes either an equation or inequality. So those are called something different because they are something different. They are not in the same category, and as you have seen on previous tests and quizzes, you will be asked to identify when something no longer is an expression. Moving on from here, a term is a section of an expression usually separated by addition or subtraction. That is what a term is, and I'll be lumping all of these examples together in one very large end example, rather than several examples spread throughout. That is what a term is. Aside from a term, we have things called variables. Now, a variable is any unknown amount, and these are usually represented by a letter. Could be X, Y, Z, A, B, C, D, any of those. The one catch, and this doesn't belong in your notes, but it's something to keep in mind. When you're handwriting variables, it's usually a good idea to avoid the lowercase l, and it is also typically wise to avoid the letter O, just because lowercase l looks a lot like the number 1, and an O typically looks like the number 0. Those are two not very commonly used variables, and when they are used, they're typically typed in italics, so it's a bit easier to tell even from a quick glance that it is not the number 1 or the letter O. If you absolutely must use them, try to stylize them in such a way that it's clear that it is not a 1 or the number 0. But that is a variable. The opposite of a variable is called a constant, and this is a lone number. This is a number that has no variable. That is all a constant is. This can be 1, 2, 3, 1/2. Any of those are constants. Anything that does not have a variable. Aside from a constant, we have things known as coefficients. And a coefficient is a number that appears to be attached to a variable. And when you see a number that is attached to a variable, that implies multiplication. For example, whenever you see 2x, that says 2 times x. Whenever you see 4y, that implies 4 times y. It is an assumption that is made by the nature of what a coefficient is. So that is a coefficient. You should already know what an exponent is from the previous video and from class. So we're going to go ahead and set up an example given all of these pieces. So for starters, we're going to go ahead and put together an algebraic expression, which is just an expression with algebra, with variables. So we have, we'll say 4a plus 17b minus 14 plus, let's see, 7q. Okay? So we have our expression here. This whole thing is one giant expression. Our terms are going to be here. This is a term. Here, I'm going to include this plus sign in front of the 17b. This is a term. Include the minus sign. Minus 14, that is a term. And plus 7q, this is a term. Each one of those 4 sections is known as a term. They are all being separated using addition and subtraction. What those addition and subtraction symbols are doing is they are marking whether or not that section of a problem is positive, like these 3, or negative, like this one. We then have our variables. We have 3 variables in our expression. We have one here. We have one over here. And one down here. Each of those are my variables for this problem. We only have one constant, which is this negative 14. And then we have our coefficients. One, 2, and a third one here. So there we go. These would all be my coefficients. This 14 would be my lone constant. And we have 3 variables and 4 terms. This is what makes an expression, but it's important to be able to take a set of words and turn them into an expression, such as word examples. But there are some key words that go along with this. So let's go ahead and have a look at those keywords now. So our keywords are going to be already on Google Classroom. They have been on there for a little less than a month now. But these are all keywords that are used to create math phrases. Things such as plus, and really isn't a big one, and is used so often, so we can kind of cross that out. Total of, that works. Altogether, increased by, combined, add, sum, together, more than, added to, in all, make, yeah, sure, make. For subtraction, we've got subtract, gave, take away, decreased by, fewer, minus, shared. Shared actually is kind of a trick. Shared can show up more often with division, so I'm crossing that out. Fewer than, less than, difference, or less. Multiplication, times, triple, product, double, multiplied by, of, increased by a factor, twice, and multiple. This one is true, but it is so unlikely to pop up, and it's not used in typical language in real life, so we're not going to include that. Division, quotient, per. I don't like per. I don't like ratio. Those two are not typically used. Divided by, half, divisor. Divided into, percent. No, we have a different set of steps when we see percent. Equals, we can actually ignore because this means it's no longer an expression. So we're ignoring that. And these parentheses words are some of the most overlooked problems. Whenever you see not so much the quantity of, but when you see sum or difference, it's a good practice to, when you initially write the problem, to use parentheses. If it turns out you don't need parentheses later, you can always go back and erase them or rewrite the problem anyways without the parentheses. But to look at some example problems that deal with translating expressions, we're going to have a look at a version of a worksheet that we have done before. Translate algebraic expressions. I think we have done 2 of these. But the very first one, we're just going to go step by step, piece by piece. The very first one says 4 divided by q. That's pretty straightforward. We have 4 divided by q. Now, it is not good practice to write the division sign, so we're going to rewrite this as 4 divided by q, and we'll write it more as a fraction. This just kind of helps us keep everything in a neater space. 4 divided by q. Done. Number 2 says subtract 9 from 6 times q. So let's read that again. Subtract 9 from 6 times q. That sounds like another piece. So the first piece is we're subtracting 9. Well, what does that mean? If we subtract 9, is that 9 minus or minus 9? Well, it's very clearly minus 9. And this piece is 6 times q. Well, now hang on a second. 6 times q, if you remember from our notes, we don't need the times symbol there. If we just write 6q, that means 6 times q. So we can go ahead and get rid of that multiplication symbol. So rewrite that as just 6q. And clearly this is in the wrong order. Minus 9 6q. That's clearly not it. This should be the first part of the expression. 6q and minus 9 should come second. This is a more proper way to write our expression. 6q minus 9. For number 3, we have 4 is added to 4/5 of w. So 4 is added to, well, that seems like it's going to say plus 4. And then it says 4/5 of w. If you remember back to our notes, of was in all caps, and it was in the multiplication section. So we have 4/5 of w. Since it's of w, we won't need our multiplication symbol. This already says 4/5 times w, 4/5 of w. Same thing as with number 2, this is in the wrong order. That plus 4 would look a lot better on the other side. So 4/5 of w, and then we have the plus 4 off to the end. Number 4, they take a step back and actually get a bit easier. For number 4, it simply says 4 minus m, and that is going to be written exactly like you might think. 4 minus m. No rearranging necessary. It is just 4 minus m. Next problem, 5 times h. You might be tempted to put 5 times h, but again, that multiplication symbol is not necessary. 5h is more proper, with 5 being the coefficient and h being the variable. Number 6, it says 1/3 of the sum of z and 9. So it starts off okay. It starts off 1/3 of, okay, well that's going to be multiplication. 1/3 of, but then it uses that word sum of z and 9. Like I was saying towards the end of that previous sheet, when you see sum, it is a good idea to use parentheses. So we will put in parentheses z plus 9. After all, sum is addition. And for number 6, we have 1/3 of the sum of z and 9. If you recall from previous units, whenever you have a number next to parentheses, it means to multiply. So we do not need to write the multiplication symbol between the 1/3 and z plus 9. 1/3 z plus 9 in parentheses. Number 7, and I suppose go ahead and give you a moment if you wanted to work ahead on these last 4 and see how you are doing. Feel free to pause the video, but do be aware there will be plenty of more practice in the ingenuity assignment that I sent home during this time as well. I'll also hopefully have some time to sit down and upload some supplemental worksheets for those of you who have worked ahead or have already finished this. Nonetheless, if you had paused the video, enough of me rambling, here comes some more of the answers. For number 7, 6 less than c, 6 less would be represented by -6. Then c, well clearly this is in the wrong order. -6c would mean something different, so we need to rearrange it. c minus 6. For number 8, it says subtract 2/5. Well, okay. Subtract 2/5 from 9 times m. Okay, well let's rearrange that because that's clearly in the wrong order. Boom, there we go. 9m minus 2/5. Number 9 says 9 is subtracted from m. Okay, 9 is subtracted. Cool, minus 9. From m. Well, this is going to be m minus 9. And finally, number 10, take away 2. Okay. Take away 2 from 6 times w. Wrong order again. And just for pure curiosity's sake, wanted to take a second and see how many of these you might have gotten wrong if all you did was write it straight across in order and didn't bother to rewrite the order of it. 1. 3 actually would have remained right because addition, it does not matter which order you do. This was just read straight across, that would be fine. This would be fine. Number 7 would have been backwards. Number 8 would have been backwards. Number 9 would have been backwards. And number 10 would have been backwards. So if you are reading straight across and not taking the time to rewrite it, you might have noticed I rewrote most of these problems 2 times. At least every single one that needed to be arranged, I wrote twice. That's because the first time I translated it, it was out of order. And that's not okay. You need to make sure that you are slowing down and taking your time to rewrite these expressions in the correct order, especially for subtraction and division. Order matters immensely with that. So, this is it for when it comes to translating algebraic expressions. In the next video, we will take a look at simplifying algebraic expressions primarily by combining like terms. See you later.